Thank you, dear friends. It's so nice to see you. Let's get right to it. Did you notice that executing the same actions in different order can often lead to different results? Even if we take very, very correct actions that normally get us to beer or some other wonderful results and do that in the wrong order, we can get into a disaster. How often have we heard, oh shit, I should have done that first? The famous thing, and it especially applies in the software development, because as we all know, premature optimization, and what is premature? Where is this point? It is pretty hard to predict sometimes. So what we're going to do today is we're going to talk about some not so obvious aspects of building the distributed system of microservices in Python and as well as in other languages without failing much, because I know that, like, yes, if you're full-time employed, getting fired is pretty hard. If you're a freelancer, it gets easier. Fortunately, we have now this whole microservice hype. Makes things much easier. You can fail in so many ways. So getting fired is really getting there. So I will be also sarcastic sometimes. So if you recognize yourself, it's not you. I don't mean anyone. I mean myself in the first place because I went through this whole thing. And let's start simple. We start with a stage 0, before even the whole microservice thing starts. Imagine that the big boss is calling you, hey, we have to talk. You think, am I already fired or what's happening? No, you're not. He says, it's time. I was thinking, I was reading a report, it's time that we go microservices. At this point, you might think, hey, but sir, we're just a hairdresser salon. We accept bookings only on the phone anyway. Like, what are we going to split into microservices? Don't do that. Don't do that. That's humiliating the boss. He perhaps read so many Gartner reports about success stories. He was thinking how he will brag in the bar with his boss friends, like, hey, yo, Jimmy, I have microservices now. Ooh, what do you have? And you offer him some Django thing? No, just do what he wants, because otherwise, if you don't, then you fail at the stage 0. You will not even get that job, as a freelancer is particularly relevant. And now you think I'm talking a bit extreme maybe, but I have a real-life case. So I worked for one big and famous company, which I will obviously not name. They hired me to fix their architecture. And when I presented my first draft, they said, all right, but where are microservices? So, what? Microservices, is that a requirement? They say, of course, I mean, looking to the future now, supposed to be an expert. So good, well, you should understand that microservices are not so much a tech solution as an HR solution. When you have thousands of people and they have to cooperate on the same project efficiently, that's a very good way to go. Or if the load has such a difficult nature, but you guys, you have like 1 request per second, peak time, they were disappointed. Like, we thought we were hiring an expert, and you're offering us a monolith? Lost the job? So let's just agree. Microservices, take it as granted. It's hype. They will come. Don't resist it. Accept it, and start forming your happy and motivated team that is just eager to jump right into that, right into the migration. How would you normally do such a big new beginning? You would perhaps read a book, and there are many good books. You have a good selection also of the cloud container patterns available now, published everywhere, even for free. But the book, I mean, the book is boring. Who reads the book? It's 2019. For God's sake, we have Google. Google is a new book. Google is all we need. Why would you read 500 pages in advance? Your team will be so upset. So if the team wants to just prototype, you know, freedom of choice, and the freedom is a basic human right, they will be upset if you don't let them prototyping. You might lose your job. So don't do that. Let them prototype, because Google-driven development is actually not that bad. It's not as bad as Stack Overflow-driven development. Who knows the difference? Difference is that Stack Overflow is when things are already on fire. So if it's Google, they are sort of planning it in advance. All right, now let's go a bit more serious now. Let's go deeper down to the stack. Stack. You have to design it from scratch, and here, to be correct, I have to say stacks, because we have a new fancy polyglot infrastructure. We have many languages, and it's not just about the languages, because every language has own stack, every language has own tools, own build process, and now we have many of these. Wonderful. You know, when you push Python code, you perhaps do pylint, you perhaps run tests, you package it somehow, flake it, whatever, build a Docker image. That's one way of doing it. Now imagine the next thing you have is Java. You'll get to know Maven, the beauty of Maven, or Ant. You will pack things differently, some jars or wars or whatever they're using. And now, imagine we have front-end as well in the stack. You have JavaScript. Wow, you would have to minimize it, add shims, concatenate stuff, Babel, other things, a wonderful life. And then if it's really, really front-end, then the Webpack, Gulp, Grunt, oh, that is so much fun. I have a perfect illustration for this I took from the JS Congress in Munich. It says there are milk products that last longer than some JavaScript frameworks. And that totally reflects the situation of the front end these days. So yeah, your stack will look perhaps like that, and just share it with the ops. Ops will be so happy to see it. Like, they either jump out of the window or throw you out of the window. So get prepared, get your team with you so that it won't be you. But of course, you can always say it's better than a monolith, an old, ugly monolith, this nasty Jenga tower standing out there ready to fail. We're going to fix this with microservices, and it will be way more elegant. There is a surprise waiting for you, because if you migrate from here to microservices, 90% of cases you will get many little Jenga towers instead of one big. On with its own stack, on with its own bugs, and with own hacks to keep it somehow stable and alive, you know. Now imagine that we have micro teams, right? Imagine there are just 1 or 2 people working on each Jenga tower. It's a good thing. You cannot get fired because they depend on you heavily right now, so. They will probably not fire you, the smart boss would probably vaccinate you against everything in this world, because like, their business depends on every little piece of this, and you're basically irreplaceable. I love it. As a result, what I call it is an epic zoo of technology. Imagine the front end is on React, statistics is on R, and then you have some admin side PHP legacy, you have accounting made in Java, you have to maintain that whole thing somehow, and these components, they bark, some components meow, and then other components roar, and yep, sorry, I forgot the fish. Fish is important, but it just writes logs, so it can keep silent. Now, imagine, how can you possibly manage this whole thing? How can you keep this component sane? And well, for keeping it sane, we're going to the next chapter, even deeper, even more concrete. We are going to repeat some wisdom of bigger companies that did it in the past already. Imagine the new team member comes and says, I don't care, it's all in Python. I want my new fancy microservice in JavaScript. What you have to do? Beware not to offend him or her. Should be polite, and you just use the wisdom of Netflix. Netflix had this issue. They had the whole thing done in Java. It worked perfectly until they hit certain architecture limits, so they had to split into microservices, which were Java microservices, and then they grew, and eventually they had to deal with other languages as well. So they developed a very, very smart strategy that worked for them at the beginning. They said, of course, at Netflix, you're very welcome to pick any language you like. You have a total freedom in doing that. But just in case, that language you'll pick will be Java. You'll get a failover, you'll get a discovery, you'll get logs, you'll get monitoring, all for free automatically. But if it's not Java, well, you're very welcome to implement it in your language of choice. And at this point, most of the developers said, maybe Java is not that bad option. What I wanted to say is that at the first stage, all right, let's say you have to split your monolith into many components, but that doesn't mean you need to have that zoo right away. You can still stick with 1 or maybe 2 platforms that will be well-tested, that will have a well-defined process on the ops side of building things, on testing things, and on deploying things. So it costs a lot, especially in the beginning, to integrate every new process in your architecture. So if you can avoid it, just avoid it at the beginning, and you can pick just one reliable, well-known language such as Java and work with that. Kidding, no worries. So let's say we take Python. We need still to decide on the exact tools that we are using in Python to write microservices. And here I'm just going to quickly jump over the most popular framework and choices that we have. Let's start with Django. That's not a joke. I mean, if you're damn good in Django, you can write a microservice in Django. I know people who did that. It feels to me like going grocery shopping on a truck. Nonetheless, yes, you can do that still because Django is still like this very, very flexible plugin architecture which you can customize, where you can throw useless things out and you have wonderful pieces like an admin panel there automatically. But the problem is that if you take Django by default, it has so many components. So if you think of that, actually, each component could be a separate microservice. So it doesn't really make much sense to use Django as it's shipped to you. It only makes sense if you cut things you don't need out. Then it's fine. And speed-wise, I mean, we don't have to discuss Django. We all know its advantages and disadvantages, but it is still doable. So here many would suggest Flask. Flask, everyone loves Flask. Flask is so minimalistic. It fits so well the whole idea, the whole concept of microservices because it does just one little thing and it does it right. I like Flask. I mean, Flask is okay. It's not the most fast web framework, but it's a comfy one. What I like in Flask is asynchronous networking. And this is particularly useful for microservices because when you have a chain of requests from one microservice to another and they are blocking and one thing fails and the whole chain is blocked and does not serve more requests because potentially, I don't know, it gets out of the workers in the pool, that's bad. That's not cool. So I strongly prefer and suggest you to use the synchronous tool so that you are not blocked if one of the components is blocked and you don't have a limited amount of slots of the parallel requests that you can process at one point of time. So there is a solution. There is Quart. Quart is a replica of Flask. It's just a synchronous copy of Flask, let's say. I didn't check it out in production. I just know it exists. I played with it. It has the very same API as Flask does. I think they are developing it further now. But it's a good option. Nonetheless, as I said, I didn't check it in production. Flask, I did. So if you were a Flask person, and I know Flask is a much better framework because it has a cooler logo and it's minimalistic. It's like Fiat 500. It's a minimal thing, does all you need, looks fancy for those who do not need to compensate, with a big scale. Totally love Flask. Now, I'm just going to quickly talk about other options there. There is Hug. Who knows Hug? Hug is great. Hug is based on Falcon. Falcon, they say by the benchmarks that Falcon is the fastest web framework in Python by amounts of requests per second it can handle. Falcon wins. It's synchronous, but it's very fast. And then Hug is a sort of abstraction over that simplifies building API. It's like Django REST for Falcon. Makes developing RESTful endpoints very easy. Generates with a command line interface right away because remember your microservices not necessarily have to communicate over HTTP. It could be that it's very useful if you have something like Amazon CLI available right away. You create a normal RESTful endpoint, you have a console interface automatically. That's pretty handy. I used Hug in production. Does a great job. And then there is Tornado. Tornado is 15-year-old now, as far as I remember. It's super stable, it's asynchronous, it's well-tested, well-documented. It's like more the older version of async.io, let's say, that supports Python 2 as well, which for some cases, because usually when you come to a project that wants an architecture upgrade, the chances are that they have a lot of components written in Python 2. So with Tornado, you can have fancy synchronous communication right away. Since 2.6, they sort of simulate the yield from or async await thing with just normal Python generators, so you can use yield. You can use yield with Python 2, and it just works very similar to the way async.io does. I'm not putting async.io on slides because that is so obvious. Like that's the default thing you'd go with HTTP and async.io. That's now the default way to go. Now the project grows, and thanks to Python, of course, at some stage we hit the point, as Netflix did, where we cannot resist getting new languages and new stacks anymore. So what can we do then? Then we should use the container patterns. And there are books published, there are articles published, and also many, many videos on YouTube about that. I'll describe 3 most popular patterns that are used and that I checked personally. Let's start with a sidecar. Sidecar is a sort of an extra container that you put next to your main container that would enhance it. To be more precise, here is how it looks like. Imagine that you have a main container, which is a web server, and your sidecar container is a log-saving application. Why would you need to separate it, you might ask? You can have your main application and something like a Sentry agent that collects your logs or Kibana or whatever. The trick is that every web server, even super old one and super legacy one, can write logs to the hard drive. And not every old framework has Sentry integration. So we go a bit another way and we say, let's just assume every app can write logs to the hard drive. And we take another container that would pick logs from the hard drive and send it to whatever cloud aggregation system. This way we separate totally the responsibilities of these two. We say that the web server should just do the web-related job and save logs as it can. And it's a job of the Sidecar container to pick these logs up, process, do the whole routing, find the right cluster to submit it, this sort of work. This is the first pattern that you can use. And the second one is ambassador. It's a very similar concept, sort of a big important fella that you have to speak to instead of speaking to some even bigger entity. This is especially useful when you are dealing with some remote resources like a database or a Redis cluster. Ambassador will hide it for you. Ambassador resides on your local host. It runs next to your main container, and you only communicate with the ambassador. It simplifies a lot because in your super huge application, you perhaps have a super huge Redis cluster that every component that speaks to has to maintain. You either need the IP or DNS, and if it's failing, then you need a new route. So this is all job of the ambassador. And the ambassador is always on local hosts, the same port. So if anything fails, it's a job of an ambassador to get the new route, find or maybe do some graceful degradation in this case, or caching things as well can be done on the ambassador level. So this is also a pretty common pattern, very useful when you're writing big distributed systems. It is particularly useful because, as I already mentioned, when the new language comes in, it does not affect the main container. You can have a main container in Java, and you can have your ambassador in any other language. They communicate over standard protocols, standard ports. They're totally running independently. Now, finally, the adapter. The adapter looks like an ambassador, but the reverse ambassador. If the ambassador pattern represents an application, your main application, with a simplified view of the outside world, the outside cluster, then the adapter does the reverse. It simplifies the view for the outside world of your application. To give you an example, imagine the monitoring case. Like perhaps we want to have a health check on our main application, and different frameworks, different applications serve on different protocols. They have different ways to check if the app is alive or it's down. Some would provide you a URL like /health or whatever. Some would write in a file in Unix that would say, file is there, then I'm up. And some would just not do anything. You would have to do ps aux and check if the process is running in the Unix machine. So we can use adapter to help the outside centralized monitoring system to get the status of every component, because we will ship this monitoring adapter next to our main application, and the adapter will know how to check if the main application is dead or alive. It would know if it should check a file or check a URL, and so then the external part, the monitoring system, would just use the same way to ask the adapter if the system is running or not. This way you can also scale framework independent, and you can keep the same monitoring system on a very, very, very diverse zoo. Good. Now, quickly going to the functionality after we know the patterns. As we already discussed, microservice usually has some business logic, like the main thing that it usually does, either serving some crude operations on the database or doing some monitoring or something else. And there are always communication functions, which are repetitive across many different projects. It makes sense now to take these communication functions and put them in a sidecar, the patterns I already described to you, because they are very repetitive. They do this failover and discovery and graceful degradation thing. It looks much more elegant like that, but we still have one problem. Now, we offloaded all of the functionality of network functions to the sidecar. However, nonetheless, how should different applications find each other? You packed it into sidecar, but what exactly is the sidecar doing? How is the network communication and discovery happening? You need to communicate with not only with a database, your components perhaps also need to communicate with each other. And how exactly can this be done elegantly? You can, of course, put ambassador for each service, but you know it will quickly get insane. You can break things and lose your job. So you need a better way of establishing communications, not just with a big Redis cluster, but also with the components talking to each other, like small dots. And here we can finally introduce the concept of a service mesh. It's a new step. It's a bit centralized. It's a centralized component that keeps track of which service is doing what and available where. And so the idea is that the communication between our little services, they do not communicate only over service mesh. They just use service mesh to find where are other components located. They still communicate directly. So this is like DNS on steroids, basically. You can say, I can just use DNS at the beginning, but DNS depends on caching, and in such an architecture, you cannot afford caching too much, because if a system fails, you need a very, very quick replacement for a failed system. And that's exactly what service mesh does. So you can think of it just as a better DNS system. And to be more precise what exactly it's doing, I have a list here. Like you normally offload tasks like routing, access control. It's another big thing that I'm not discussing right now, but when you communicate within microservices, you need to decide on the common way how, if you encrypt the data, how exactly, how do you decide if one service is allowed to ask another service of a particular operation? Then there is always a context of, are you asking one microservice to another on behalf of user, or you just need some meta information? All of these little things you have to do repetitively in every new microservice you bring into your architecture. And not to do that, you offload these repetitive tasks to the sidecar, and the service mesh is just maintaining the list, something like the access control list, routing list, task list, and so on. Good. Finally, I want also to say a few words about the failover. People say graceful degradation and short-circuiting. There are many fancy ways of saying, how would you elegantly tell your users, I'm down? It's way more easy to bring the system down when you have many little services, because it's a chain. If one element of a chain fails, I mean, if instead of showing error 500, you're showing a message, I'm sorry, we're currently not working, it's more elegant, but it's not good. So instead of putting effort in this short-circuiting and failover, I would strongly suggest you to put your effort in better logging and better tracing. There is an open trace standard that was developed especially for this case when you have a big system and it's hard to debug it, it's hard to trace where exactly did the request fail. Instead of putting your effort into excuses, like I'm sorry we couldn't do it, trace it, log it, have a system. When we have here sponsors, what was the Datadog people, like they do it. I use Datadog for that. I'm not advertising them, but also New Relic does it. Invest your time there. Build a reliable system where you can easily trace every request, and every time you can say, if something fails, it was fault of this component. Because without this, you will pretty certainly eventually lose your job. Thank you for attention, and I wish you a very nice zoo of your microservices.
Thank you, Anton, for this refreshing talk, and we now have time for questions. So we have microphones on the side, or I can also move. Okay. So in the meantime, while they get inspired, I wanted to go back to your recommendation on basically the frameworks. And there has been quite some articles about and talks about why frameworks can also constrain you a lot, especially when you want to iterate over your product or, let's say, add new features, because they basically fix the way the business logic is defined. So would you have also some recommendations there on maybe just smaller libraries, or how you would approach that if basically rewriting is not an option?
Yes, of course. Well, one trend is things like Lambda functions on AWS. Many people do it. Many people do it successfully. There is basically no framework. That's just a function. As long as it's simple, it works. However, if you're not so much afraid of leaving that project and you think that there should be another person replacing you eventually, frameworks are like a common patterns that other developer knows. If I leave a project and I tell you it's just the Django REST endpoint and you can find right away it's a post handler, it's a get handler, and you can just continue working right away. If you do a customized system, obviously it's harder for new people to get into it. On another hand, there is an overkill of using a framework, especially in microservices, because even Tornado, it's quite minimalistic. Nonetheless, it has also, as Django does, many batteries included, like CSRF protection and so on, which you normally would not need in microservices. So you're right, it's always a trade-off. When you pick a framework, you make things simpler for yourself and also for people who will be working on the project after you. If you do it yourself, you usually can tailor it better. You maybe can do it even more efficient, but there will be difficulty in maintaining it when it grows. And then don't forget the testing. You would perhaps test things a bit differently when you write microservices, because it's not so much about unit tests in microservices as about integration and acceptance tests. You need to check the whole chain, not just one thing. And here, testing frameworks that act predictably is sometimes just simpler than testing custom code that is not so predictable. For others, not for you, for others that test their component, speaking to your component. So yeah, but there is no black and white answer.
Thank you.
Thank you.
You said about error propagation
Yes.
at the end of the presentation. As Fowler said or discussed in his blog post about microservices, the reason is for this error propagation is synchronous communication. And the problem is that when you add microservices to your system, probability of going down actually increases because with each microservice that can go down. Mm-hmm. So the solution is asynchronous communication between microservices, and it may be HTTP or anything else. But did you try it, discuss it? What can you tell about switching to asynchronous communication?
If you mean just switching from synchronous HTTP to asynchronous HTTP, it will not change much. The protocol is the same. It's just what I meant, at least in my part, was that the framework, the web server behaves differently. Instead of blocking one worker doing one request, you have the IO loop that would handle that request as soon as it's not hitting any IO boundaries. And if you hit IO boundaries, which you always do in microservices, because you're always waiting for either a database or cache or another microservice, it can serve other requests as well. That is what I meant with asynchronous communication. I do not see the effect of this on the error tracing, because the protocol is the same, it's still HTTP. As a client, you should, in the best case, not even notice that it's asynchronous or it's synchronous. Regarding the error tracing, yeah, and again, I didn't mean error tracing on the client level, like the HTTP error codes, like error 500 or whatever else, as I meant error tracing inside the application, because your request is passing through so many systems, it's hard to match by time, for instance. That's a typical first step that developers do. When something fails, they try to find logs on that point of time. But it is going so fast that you perhaps will have a hard time figuring out, because at exactly the same time in many, many services, many things could have happened at the same timestamp. So it's harder to do this chaotic time-based debugging, and you need more centralized tool that collects all logs and that somehow is marking every request with some headers, which are then passed around from one microservice to another, so that you can trace it from the entry point till the exit point, what exactly happened where. That is what I meant with the error handling.
Sure, that's correct, but I was asking more about dealing with unavailable services, for example. What do you do when you issue a request to a microservice that should be there, but it's not there? Maybe it's not there for like 10 seconds, and the question is, will your system be failing for this 10 seconds, or will your system be resilient and be able to recover.
Of course, this.
I'm sorry to interrupt. We will have to stop here now, so I would suggest you to continue that during the small break we have. So let's thank Anton once more, please, and then we have a break.